we start chemical formulas and chemical compounds. And like I said, this is where you start to sound a whole lot smarter than you have up to now. You start to sound downright brilliant, and you can go to the grocery store and you can pick up a can of, I don't know, corned beef hash, and you can say, oh my gosh, this has got sodium nitrate in it. Won't your family be impressed? Okay, so the first thing we're going to start to talk about is what is a chemical formula. There are two big categories here. We actually talk about them differently and we name them differently. So, for molecular compounds, we have molecular formulas. And those show actual numbers of pieces, number and type of actual atoms in a single molecule. So, sugar is the one we always use, C6H12O6. You have been doing Lewis structures for molecular compounds. The Lewis structures you've done have all been molecular. So, and polyatomic ions. Sulfur hexafluoride, which you've drawn, you've built. 1 sulfur, 6 fluoride, 6 fluorines. It's a real thing, that molecule, and you've built it, so you have a good sense of that. Ionic compounds are different. We kind of started to talk about this in the last chapter, but we just kind of skimmed the surface, and now we're going to really go into depth with it. It's just a ratio. So there's no individual unit, it's just a ratio. So, for potassium bromide, KBr, it's 1 to 1. For calcium bromide, CaBr2, it's 1 to 2. So you're going to get really good at deriving those ratios. So this is, the important thing to know is it's just a ratio. Why don't ionic formulas show the actual number of things in a molecule? Why don't ionic formulas show the actual number of pieces in a molecule? Because there are no molecules, right? That'd be a molecular formula. Yeah, that was a Grant's Tomb kind of question. Some of you looked like you thought it was a trap. It wasn't. Ionic formulas can't show how many things are in a molecule because there are no molecules. They're ionic compounds. It's just big conglomerations of positive and negative ions. Okay, so we're going to start off with ionic compounds, and we're going to start off talking about monoatomic ions. You all actually have a pretty good basis in this at this point. So we pretty much talk about monoatomics, and mono means what? One. Think of the monocle, the single eye piece. So these are ions made of a single atom, and you've been, for the last couple chapters going, oh yeah, that one's going to lose 1, this one's going to gain 1, that one's going to gain 2. You've been practicing forming monoatomic ions. So we know that they do it all to be just like a noble gas. Everybody wants to be like a noble gas. So group 1 and 2 tend to lose electrons. Remember our friend sodium. Sodium's hanging out in a sketchy neighborhood, shots are fired, sodium calls the police, and sodium says, there's a sniper in my neighborhood! I've been hit! I've lost an electron! And they say, are you sure? And sodium says, I'm positive. You can use that later if you want. I'm positive because it lost an electron. Okay, so group 1 and 2, they form positive ions, happy little cats, because they lose electrons. Group 15 through 17 gain. And the D block, remember how I keep saying the D block is weird? Let me say that again, the D block is weird. They do form cations, they always form cations, so this is transition metals, but a lot of them will form multiple cations. So iron can form Fe2+ or Fe3+. Chromium is the all-time crazy winner because chromium forms chromium 1, 2, 3, 4, and 6, I think. I don't know if there's a chromium 5. Actually, I'm not sure about chromium 1, but I know 2, 3, 4, and 6 I have to look up the others. It's crazy, absolutely crazy. And chromium-6 is incredibly toxic. So yeah, the D block form a bunch of different kinds. And Monday you are going to receive a gift from me. It'll be so exciting. It'll be your giant new ion Bible, and it's the thing that you will sleep with under your pillow, probably get tattooed on your forearm, you know, maybe request multiple copies to paste up in your house, and it'll have a lot of the common D block ions on it. Okay, you might not get that carried away, but maybe you tape it to the dog. I don't know. I don't know what you want to do. Oops, that's the same darn thing. Okay. So we have to have something to call an ion. We can't just call it hey you. So when we have a cation, we just call it by the name of the element. Na1 plus is a sodium ion, Ca2 plus is a calcium ion. Grab your periodic table. What would K1 plus? Yeah, that's just a potassium ion. What about magnesium 2 plus? Somebody with orange or yellow? Wow, okay. Sabrina will take it. Magnesium ion. Yeah. These are really, they don't change anything about them. Okay. When we make an anion, we do change the name. So, you know, with a cation, it's like they just get a last name. You know, magnesium ion, calcium ion, strontium ion, barium ion. With an anion, whoops, the ending of the element name is dropped and you get an IDE. Here's something I'm going to tell you. That IDE is incredibly important. Because not today, probably Tuesday, you will also have ITE and ATE to contend with. So I want you to pay very close attention to the fact that IDE is a different thing. Okay? Like, commit that to memory. So when we take a chlorine molecule, oops. When we take a chlorine molecule and we suddenly make it Cl1 minus, it's no longer chlorine, it's now the chloride ion. Same with sulfur. We take a sulfur atom, we add 2 electrons, it's now a sulfide ion. So, let's practice this. Oxygen, 2, let me get rid of this. Cut. Oxygen 2 minus, somebody in red. I have multiple candidates for this. Oxide ion. Yeah. These are the ones that have all the tricky ones. People get really weirded out about a few choice ones, and I'm going to give them to you. Nitrogen with a 3 minus charge. Somebody in black or gray. We got lots of black and gray today. Let's take it. Tyler. Nitride ion. Okay. Nitride ion. Okay. I've saved the weirdest for last. What do you call iodine 1 minus? Somebody in gray or white? Who I haven't heard from yet. Take it, Mark. Iodide. Good job. Yeah. Everybody stumbles over that one. Iodide. I think it's fun to say. It's the iodide ion. Okay. So that's not really complicated, but get accustomed to seeing that IDE means this is a monoatomic ion, because the ITE and the ATE are polyatomic ions. So So you'll just have to be able to distinguish that. When we get out to the D block, remember how we said they make multiple ions? And you probably had this in physical science. Do you remember any of the stock system from physical science, the Roman numerals? Do you remember anything from physical science? Okay, you were freshmen. Freshmen are all squirrely. We have to designate which ion we're talking about. So, you know, copper forms copper 1 plus. It also forms copper 2 plus. And what's interesting, especially about copper, I think copper's so cool. Did you know that copper is antimicrobial? They've done experiments in hospitals. They've done research because, of course, hospital-acquired infections are a huge risk. Going into a hospital is incredibly dangerous for you because there are all kinds of nasty pathogens lurking around on surfaces, and you can pick up an antibiotic-resistant infection really easily. They have done trials with hospital rooms, especially in high-risk units where there is a lot of infection, with installing copper handrails, bed rails, and everything else, and the copper forms enough ions on the surface it kills bacteria. How cool is that? Now, you know, your hands probably turn green. Who cares? It's better than being dead. And copper has that funny coppery smell. You know what I mean? Okay, you all know what I mean by the coppery smell. It's the, does this make sense? The smell that you taste if you get a cut in your mouth and you taste blood. It's that coppery blood smell. Anyway, yeah, so copper, pretty cool stuff. Copper ions, so when you have a compound made of copper 1 ions versus a compound made of copper 2 ions, they're different colors. It's just one electron, right? One stinking electron. Again, this is the thing that just blows my mind every time. The world you see is the way it is because of these little tiny things we can't see that are buzzing around all the time like some sort of swarm of invisible insects. Holy cow. So, and I can never remember which is which. Copper 1 ions, I think, are blue, and copper 2 ions are green, or vice versa. Turquoise is a mineral that's formed in association with copper. So that color, that blue turquoise color, is it's indicative of copper. And you saw that in the flame test. Your copper burns sort of a bluish green, like a teal. Malachite is the other, and I should have worn my malachite earrings. Who knows what malachite is? It's another mineral gemstone, also found near copper deposits, and it's a really beautiful, like Kelly green, and that's the other color of copper. When we go to the Carnegie Museum in the spring, we go to the mineral hall, and they have you look at the copper and the malachite samples and find the chemical formulas for them. So it's kind of neat. So we have to somehow distinguish. I mean, there are some serious differences here. Different colors, they have different characteristics. So to distinguish them, we name them based on their charge. I'm going to shrink this. So this is like a Grant's Tomb question again. Guess what we call Cu1+. You're never going to guess. That's what it is. What do we name it? Copper 1. Guess what we call Cu2+. Copper 2! Like I said, these chemists are endlessly creative. And we designate those numbers always with a Roman numeral, always in parentheses. So, if I come along and ask you, hey, what is the charge on an iron 3 ion? Hey, what's the charge on an iron 3 ion? +3. Okay, so that's pretty easy. Let's practice a few of these. What would you call the following? That's vanadium, by the way. V is vanadium. So, somebody wearing shoes that do not have laces, who I have not heard from yet. Shoes with no laces. You got laces out the wazoo. Huh? It's vanadium? Vanadium 4. And you would write it like that with a Roman numeral. So This is, well, no, I talked about chromium, so no, let's not do that one. Let's do, SN is tin snips. That's a good way to remember it. What's that one called? Somebody who has on pants that are not jeans. Anything that are not jeans. Somebody who's not wearing jeans. Okay, who I haven't heard from. Madison, you might be the last candidate who I haven't heard from who's not wearing jeans. It's tin. Tin 2. Yeah. Hey, look, I got a neat tin 2 over the weekend. Ha ha ha, I don't know. Okay, so that's easy. You can name ionic compounds. Good. This is where we learn to write our first formulas, and then you will practice. And then you will take a FIP quiz on Monday. It's that fast. When you name a binary ionic compound, first of all, let's talk about what that is. So bi means how many? 2. Binary ionic compounds are made up of 2 things only. Just 2 ions. Binary ionic compound. So the charges have to be balanced. So, you know, with sodium chloride, we've got 1 positive, 1 negative, they balance. To write the formula, so we're going to go at this 2 ways. We're going to go from, I give you the ions, and you write the formula, to I give you the formula, and you give me the name. Okay, so it's sort of the backwards process. It's like a reversible reaction. So, do you remember doing the crisscross in physical science? You were probably taught the crisscross. You may or may not remember it. Okay. I know some of you claim to have no memory of your freshman year whatsoever. It's unclear if you were kidnapped by aliens for the entire 36 weeks of school. I understand. I've had years like that. That's okay. So let's say we have a compound with calcium ions and fluoride ions. Okay? So I tell you that you have a compound made up of these 2 things. How do you write the formula for this? Your first step is always to write the ions. You will need your periodic table out if you do not have it out already. And I have spare periodic tables. I haven't coughed on them or touched them, I swear. Okay, so your first step always is to write the ions. So what kind of ion does calcium form? We know it's Ca. What's the charge? Okay, find it on the periodic table. What group is it in? Hold up fingers for what group it's in. Okay, how many valence electrons does it have? What will it do? Ditch them. Throw them overboard. 2 plus. Sodium, I've been hit, I've lost an electron. Are you sure? I'm positive. Okay. I know, I got it the first time, Moser. Will you please quit repeating your stupid jokes? We don't need them, okay? All right. So calcium forms 2 plus. What does fluoride form? -1. Good. 1 minus. So what we do is the crisscross. You know that, so a couple things about writing formulas. Positive ion always comes first. The way I have remembered this for the last however many years is lead with the positive, lead with the good news. Positive ion always comes first. You take, let me scoot this over just a little bit. You take the number. You're not worried about the charge. You're just taking the number. And you crisscross them. So we're going to write those numbers as subscripts. And I think you guys all have this, but I'm going to explicitly state it. Let's be real clear. These are charges. Okay? Charges are written as a superscript, and they have a sign, positive or negative. It's a number and a sign. These are subscripts. They have no sign. They tell you how many atoms of that particular type are in a unit, either a molecule or a formula unit for ionic compounds. Okay? So like I said, I think you guys have that, but every year I like to just once at least state it for the record so that we all are on the same page. Every now and then I have somebody sneak through who has a little bit of confusion, so we'll just clarify. Okay, now what you have, let me get rid of those. Now what you have is Ca1F2, but here's the thing. We never write a 1. So we would just write the formula for this as CaF2. We simplify whenever possible. So the formula for a compound made from calcium ions and fluoride ions is CaF2. Now let's do the other half of the game. Shrink that. So this is writing the formula. The other half of the game is naming. So if I hand you this formula, CaF2, and I say, what's its name? With binary ionic compound, with any ionic compound actually, it is stupidly simple. The name of the compound is the name of the first ion, followed by the name of the second ion. You already know this because you know that NaCl is sodium chloride. And that's any time that you have any doubt about this, just go back to that in your memory and you go, oh, okay, that's all it is. So what would the name for CaF2 be? Calcium fluoride. We just name the ions. And I always screw this up. U-O-R-I-D. Still can't spell fluoride. Been teaching chemistry for 8 years. We all have our handicaps, huh? Okay. So now, let's practice doing this at a slightly more sophisticated level. Do you want me to shut up while you finish copying this? See people who are still copying a little bit. Let me pause. So now we're going to do something a little bit more sophisticated because typically you're not going to be told, oh, it's a formula composed of these and these ions. You're just going to get the name of a compound, and I'm going to ask you for the formula. So let's practice that. If I tell you that I have a lump of magnesium sulfide. Oh, you know what? Let me change that because that gets into an exception that I want to introduce a different way. Let's make that magnesium chloride. And I want to know the formula for magnesium chloride. What's your first step? Writing down the ions. You've got the names. You have the names, so you need to write down the ion. So what is the magnesium ion? Mg what? 2 plus. Mg 2 plus. What's the chloride ion? Cl1 minus. Okay. So now I'm going to do this for myself. Good? Okay. And if you're still not really automatic on knowing what ions are formed, the document that I'm going to get, maybe I'll just give it to you Monday, will help a little bit with that. The big thing to remember is group 1 forms a 1 positive, group 2 forms a 2 positive. And then it's pretty well patterned. 16 forms 2 negative, 17 forms 1 negative. So we're going to take our little numbers, number only, we don't care about the sign, and we're going to crisscross So we get Mg1Cl2. How are we going to write that formula? Somebody I have not heard from at all today. So that would be Katie, Destiny, Laurel, Caitlin Pugliano. Caitlin Williams, did you take one? Okay, I thought, yeah, you and Colin were in on one. I didn't remember. Yeah, you responded to the next one. Okay. I don't think I've heard from Kenzie either, have I? Have I? Okay.
MgCl2?
It'd be MgCl2. Bingo. MgCl2. That's your formula. That's it. That's easy. Let's do another one, writing formulas. Actually, let's do one the other way. So I give you a formula, and you have to name the compound. So let's do, whoops, BaO. You have the formula, all you have to do is what? Because remember, binary atomic ionic compounds are really easy because you just have to name the ions. What's the first ion called? Barium. What's the second ion called? Oxide. IDE, oxide. This compound is barium oxide. That's it. Yeah, it is. It's very easy. Okay, let's do one more. So we'll do calcium sulfide. Yeah, we'll go ahead and do the magnesium sulfide. Okay, magnesium sulfide. So, magnesium is in what group? 2. Forms what kind of ion? 2 plus. So, magnesium ion is Mg2 plus. Sulfur is in what group? 16. It has to do what to be just like a noble gas? Gain 2. So that's going to be 2 minus. I know. I know. So S 2 minus. Mg blank, S blank. Crisscross. Okay, now, if you can simplify coefficients, you do. Because what's the ratio of of magnesium ions to sulfide ions? It's 1 to 1. There are 2 of this for 2 of that. It's 1 to 1, so we always simplify. So the formula for this is just written as MgS. Okay? I'm going to give you a practice sheet and turn you loose. Monday, here's what's going to happen. When you walk in, you will have an online quiz on just naming binary ionic compounds. These are pretty easy, right? Good. Let me get the practice sheet.